Alright, looking at problems 4, 5, and 6, starting with number 4. Again, the initial goal is to isolate the absolute value on one side of the inequality. So we need to get rid of this 4.5. This is negative, so we are going to add 4.5 to both sides of the inequality. So here we're left with the absolute value of x plus 5 greater than or equal to 12. This now turns into two inequalities. We have x plus 5 greater than or equal to 12. We also have x plus 5 less than or equal to negative 12. And now we solve for both inequalities. On this one, we're going to subtract 5 from both sides of the inequality, and we're left with x is greater than or equal to 7. Subtracting 5 from both sides of this inequality, now we have x less than or equal to negative 17. So let's do the number line. So here's 0, here's 7, whoops, let's try that again, 7, here's negative 17. These are both equal to, so they're dark dots, close circles. So x is greater than 7, so we're going this direction. X is less than or equal to negative 17, so we're going this direction. So this is an OR. So we have x greater than or equal to 7. Here we have x less than or equal to negative 17. This is a disjunction. Okay? Looking at number 5. So looking at number 5, here again isolating the absolute value, I will subtract 2 from both sides of the inequality. So I have the absolute value of 3x is less than 6. This creates two inequalities. I have 3x less than 6, 3x greater than 6, negative 6. To solve for this, 3 is multiplying the x, so I use the inverse operation, which is division. So I'm going to divide 3x by 3. What I do to one side of the inequality, I do to the other. So I'm left with x less than 2. Doing the same thing to this inequality, divide again by 3. So here I have x greater than negative 2. Number line. So here is 0. Here is 2. Here is negative 2. Open circles. X is greater than negative 2, so I'm going this way. X is less than 2, going this way. So it's all the points in between. So we can write this as x less than 2 and, so it's an and, greater than negative 2, and this is a conjunction. And finally, number 6. Alright, so here again to isolate the absolute value on one side of the inequality, I'm going to subtract 2.9 from both sides. So here I have the absolute value of x greater than, see, 8.6 minus 2.9. 16 minus 9 is 7. This becomes 7. 7 minus 2 is 5. So I have 5.7. So that means x is greater than 5.7. X is less than negative 5.7. Number line, here we go. Number line. So here is 0. Here is 5.7. Here is negative 5.7. No equals, so it's open circles. X is greater, so we're going this direction. X is less than negative 5.7, we're going this direction. So this is an OR. So this is an OR. This is a disjunction. Again, X is greater than 5.7. X is less than negative 5.7.